My name is Andy Knight. I am the Automation Panda. Most recently, I was the Principal Developer Advocate at Apple Tools, as well as Director of Test Automation University. But about a month ago, I took a new job. I am now the Principal Architect at a small company in my home city of Raleigh called Cycle Labs, where we develop an excellent test automation platform for supply chain and warehouse management systems. So really cool new opportunity for me, a little bit of a switch. You may have seen that on Twitter or LinkedIn. If not, I've got a whole video about the new job. Anyway, we're not here to talk about me. We're here to talk about Playwright. Playwright is an awesome new web test framework from Microsoft. I am a Playwright ambassador. I love this thing. I've been using it for about 2 years now. I think it is freaking awesome. So let's talk about awesome web testing with Playwright today. I'm going to introduce Playwright with some words and slides, and then we're going to jump into code. I'm going to share this link for the code now so that you can just have it ready when you want. It's a github.com/myaccount automationpanda/awesome web testing playwright. You can scan the QR code, get it there as well. This repository actually contains a full tutorial. I'm only going to be showing a little bit of the code today, but if you really want to get your hands dirty with it, take the full tutorial instructions in this repository. I hope you won't regret it. All right, big question. Who likes to find problems in their code? Feel free to answer in the chat. It's not necessarily meant to be a rhetorical question. Some people will be like, no, I don't want to find problems in my code. Me, actually, I do want to find problems in my code, because if there are problems there, I would rather know about them than not. Because ultimately, would you rather ship those bugs to production? No, that's bad. I mean, problems happen. We live in a broken world. It's terrible. I know. We all make mistakes. It's okay. The thing is, we need to catch these problems as soon as possible. We don't want them to slip out to prod, hit customers, bring down whole system. That'd be very, very, very bad. So we know problems exist. We know we ought to catch them. But who actually wants to create the test for that feedback? Ooh, I mean, I would assume there's lots of testers in this call today. So yeah, I mean, maybe testers would like to, but not everybody does. I'm not trying to do an us versus them thing, but it takes a lot of work to do testing. Am I right? It's not easy. It's a lot of work. And so after you've taken the time to build a thing, that have to go test the thing is like double work. It's not always something that people want. People want feedback, but they don't necessarily want to do the extra effort of testing. So, and I think that's because testing is hard. I said what I said. Testing is hard. What challenges have you all faced with testing that make it hard? Feel free to pop them in the chat. I'd be curious to see what some people said. I found problems every single time, Leonardo. I understand. Here are some problems that I have found from my own personal experience. I've found that a lot of time tests are slow, especially your integration or end-to-end level tests. Tests can be very brittle if they're interacting with live systems under test versus just being unit tests. Tests can be flaky. There's race conditions that are poorly handled, or the systems under test have unexpected behaviors. Another pain point for me is when I'm joining a new project, the tests don't always make sense. Like, I read some of these scenarios, I'm just like, where did you people learn to write things? Oh my gosh. Especially if they're long and complicated, it goes over my head. You know, from a business standpoint, tests don't make money. Hard fact, but testing is a risk mitigation activity, not a revenue generating activity. And so it can be hard for business leaders to justify putting resources towards testing versus putting resources towards new features. Am I right? That whole tech debt thing. Yeah. And ultimately, when you're working on software development, testing requires changing your mental context, right? If you're a developer and you're building the thing, when you come over to start testing a thing, it's a mental shift, right? You have to start thinking about things in different ways, and that's not always comfortable. That's not always easy, and so that makes it hard. Now, these aren't the the only problems there are with testing. I'm sure there's others. These are just ones that I have personally felt myself. So feel free to keep popping things in the chat. So I'm curious to hear what y'all say. Mm. One way that we have tried to mitigate these pain points with testing is having a what we call the test pyramid, right? A strategy for the kinds of tests we should write. Now, love it or hate it, pyramid is what it is. It's ingrained. I mean, but I'm not here to support or fight the pyramid. What I'm saying, what I'm trying to do right now is kind of explain why the pyramid is shaped the way it is, for better or worse. The thought historically has been that small bite-sized atomic tests close to code are at the bottom of the pyramid because you want more of those kinds of tests. They're easier, they're safer, they're faster, they have all the benefits of the goodness of testing. And so we want to focus on those kinds of tests mostly. And the more you go up the pyramid, the further away you get from the code, the larger your tests are, the riskier the tests are for things like flakiness and not being able to pinpoint certain issues. And so while those tests are important, they have been deemed as not as important. You should be doing fewer of those, right? And so a lot of teams will be like, yeah, unit tests and component tests, we got that. Maybe you'll have some API tests, but UI tests have kind of been labeled as bad because they're big and they're complicated and they're slow and they break a lot. And that's kind of how we framed our worldview with testing, which is really unfortunate because it's not that any one kind of test is better than another. It's more that we need to mitigate risk at different levels and layers of our applications and our software that we're developing. And UI tests are very, very useful because they actually test the applications or the systems as a user would. It brings all the things together in like an end-to-end kind of sense. And so we shouldn't be thinking about these things as bad. Rather, we need to be rethinking our whole approach to testing techniques. And so I think it's time that we reassess what our testing goals should be for modern software development. And so I have 3 points that I want to challenge you all on. 3 kinds of goals I think that we should have. Number 1, we should focus on building fast feedback loops rather than certain types of tests. To me, the kind of test you write doesn't really matter. I don't care if it's unit, API, UI, command line, whatever, right? What matters more is that we want whatever kinds of feedback loops we're building to be fast, right? We want to make sure that we are putting feedback loops on the most valuable behaviors, whatever they may be. And we just want those feedback loops to be as fast as possible, right? The faster we get information back, the easier and quicker we can pivot when we find issues, right? So I don't think we should be putting percentages to certain types of tests. Focus on fast feedback loops. Secondly, make test development as fast and painless as possible, right? It shouldn't take weeks to months to develop a test framework so you can write a few test cases, right? Testing, like I said, does not generate revenue for your business. It is a risk mitigation activity. And so we should be doing just enough of it to make sure we mitigate the business risks satisfactorily. And so we need to spend as little time as possible doing tests. Not to say testing is unimportant, but rather we need to be spending time on other things. And so if we can make our test development fast and quick and easy, then we can get more testing done in less time. And then third modern testing goal, we should choose test tooling that naturally complements developer workflows, right? That gets to the whole mental context switching issue, right? If we can make it easy to automate tests and we can use the same tooling, we can make it more efficient. Therefore, we can get more done in less time. And this is where I think Playwright as a modern test framework can really help us. As I said before, Playwright is a new, relatively new open source web test framework from Microsoft. The way it works is it manipulates the browser via super fast debug protocols. It's kind of like going in the back door of the browser. This is much faster than Selenium that uses the WebDriver protocol, and Cypress, which uses in-browser JavaScript. Playwright can work with all the major browser projects, so Chromium, Firefox, and WebKit. One thing that Playwright does is it doesn't necessarily work with the big browsers. So you're using Chromium instead of Google Chrome, or WebKit instead of Apple Safari. There's a small risk of certain behaviors might not be captured, but it's very, very small. I've never had any issues myself. I've only ever seen like one article about one time there was some weird caching thing in Safari that wouldn't have been caught by this. Very, very, very fringe. Nevertheless, you can test on Google Chrome and Microsoft Edge with browser channels. I personally like Playwright because it is a modern, feature-rich framework. It's not just a browser engine. It is, or a browser automation engine. It is a full-fledged testing framework. So it provides things like automatic waiting. There's a UI mode. You can generate tests. Look up locators, full trace. Everything is baked in. It also can test APIs as well as web UIs. And it has bindings for multiple programming languages. Now, unlike Cypress, that's just stuck with JavaScript, Playwright you can use in JavaScript, Python, Java, and C#. And of course, with JavaScript, TypeScript as well, which is recommended. And I'll be showing TypeScript today. How Playwright handles its browsers is also a little bit different from some of the other tools. If you're familiar with Selenium WebDriver, you'll know that the recommended practice is usually one browser session per test. So that at the start of a test, you launch the WebDriver instance, it launches a new browser instance, you run your test at the end, you quit the browser, shuts everything down. And then if you've done that, you also know that that has a bit of a performance hit, right? It takes a few seconds for the browser to come up. It takes a few seconds to cleanly shut it down. You want to have only one browser session per test for test case independence because those things live long. Scary things can happen. Or if you're in a distributed environment like a Selenium Grid or some sort of browser WebDriver scale browser platform like Sauce Labs, Browser, Stack, Lambda Test, all those, you're stuck with one anyway, or one per test anyway. But like I said, that creates a lot of test execution overhead, a lot of arguably wasted time. That's just automation concern. Playwright is much more optimized. With Playwright, there is one browser instance for the entire test, just one. Now you might be thinking, wouldn't that violate test case independence? No, because every test gets a browser context from that one instance. A browser context is kind of like an incognito session. It's got private storage, private cookies, all the stuff that would be private for basically like one incognito session. And contexts are lightning quick to create and destroy. So you don't have that multi-second overhead of start up the browser, shut down the browser, or the whole memory footprint that goes with it. And so you can have multiple contexts in parallel at the same time with only one browser instance. And that's how Playwright's able to be so fast. Within every browser context, you can have one-to-many pages. And the page is through the mechanism through which Playwright manipulates a page in a browser. So most testing, you'll only ever need one context and one page per test. But if you needed multiple pages per test, you could have that. For example, if you click a link and it opens up a new tab, you might have two pages like that. So pretty cool optimization with Playwright there. Right now, the big three browser automation tools are Selenium, Cypress, Playwright. You may have used some of these before. Historically, I've used a lot of Selenium and a little bit of Cypress. There are key differences in how these projects are run, who's backing them, and how they manipulate the browser. It's not to say any one tool is better than the other. It's more of choose the best tool for your needs. Personally, I think Playwright is excellent. For the kinds of projects that I'm working on, Playwright makes the most sense. So, but you know, that's not necessarily a universal take. So do the research. Feel free to ask questions if you're not sure which one to pick. It's all good. So with that being said, let's flip over and look at some code. As I said before, all the code is in GitHub. You can have, uh, not only is there example code out here for Playwright, but in this tutorial folder, you'll see full instructions if you want to take this as a self-guided course. It'll probably take you a couple hours to finish max, but definitely give that a try. I'm going to walk through this in Visual Studio Code. Oh, I see a quick question. We also use Selenium Grid. Can we use Playwright with it? Technically, yes. You can use Playwright with Selenium Grid. There's a page on their docs that explain how to do that. However, I will recommend that's not the ideal case. You probably want to set up your own kind of scale out architecture if you're using Playwright at scale, just because there would be inefficiencies with Selenium Grid. I should also mention that Microsoft has recently released a new Azure service for scaling Playwright test execution. So definitely check that out. That's like hot off the press only about a week or two ago. Really, really cool stuff. Okay, so rather than jump directly into code, what I'm going to do is I'm going to launch Playwright's UI mode. np. Oh, someone asked, can you drop the link here for the repo? Let me do that real quick. That's a good idea. Boom. Bam. There you go. Ta-da. Okay, back to the code. So I'm going to launch Playwright in UI mode. All the project I'm sharing today is written in TypeScript. A lot of times I do it in Python because if you know me, you know I'm a Python guy. But this one is TypeScript. TypeScript is the most popular binding for Playwright by far. Anyway, I'm going to launch the project in UI mode. And what we'll see is a window pop up here. Now I'm hoping the text isn't too small for sharing the screen here. But ultimately there's this window. It's kind of like the Cypress window if you've used Cypress before. On the left sidebar, you see all of the tests in my project. So the basic tests that, if you were to create a new Playwright project from the command line, out of the box, it gives you some demo tests. One of them are the example tests. And so here I'm going to click these tests, this example spec TS. You can see down in the source window, you can actually see the Playwright test code. We'll step through what this means in a moment. In the main area, it's just got an empty browser window. This will show the trace as well as the timeline. I'm going to play or run these example spec tests. You didn't necessarily see the window pop up, right? Because it was just so fast. It took not even 1 second for each of these. But if I click this one, example test has title, you can see there's a full trace of the steps. So in a before hooks, it calls Playwright go-to, loads a web page, which happens to be the Playwright homepage. And there's an assertion performed. Expect the page to have the title given by whatever it is. Oops. No, they're the before hooks. Sorry, fixtures. These are the main actions. After hooks, cleanup. You can see there's another trace here. Go to, locate or click, expect to have URL. And you can see a visual trace as well as a logging trace is captured for every single step here. You can even have the timeline for when the test runs, loading the browser, loading the page, checking things. So this is what UI mode empowers for you. It's really cool. We can do more tests. So there was a demo to do app. We can play those tests. Oh, shoot, I don't want to play all of them. I only want to. Yeah, okay, sorry. Let me try that again. Should only play these. I don't want to play all of them. So there were, as you can see, several tests here. And I mean, I'm guessing there's probably over a dozen tests. And you can see how quickly it ran all of these. Like within just a couple seconds, all of these ran. And if I were to go there, you can see it actually did run all of these to-do tests. That's pretty sweet. So I'm going to close UI mode. Let's dig into some of the code here. I like the Playwright code because I feel like it flows very naturally. Here was that example test where it was just loading a page and checking things. Let's look at this test because I think it's a bit more interesting. Underneath the hood, it uses a core test framework, kind of like Jest or Mocha. If you've seen in JavaScript to describe it should pattern, it's basically what's going on here. So you'll see you import your test and expect functions from Playwright. You define a test using the test function, descriptive name, test the get started link. All testing in TypeScript is done async. So we will inject the page via fixture. Playwright basically behind the scenes automatically launches the browser, pulls a page context and creates a browser context and creates a page in that context. And all your interactions are going to be done through the page. So because it's async, you see the await async stuff. So go to the page, page.goto. To click something on the page, we have to use locators. So page.getByRole. GetByRole is a special locator where you're providing, it's a link role with the name getting started. It's a little bit better than like an XPath or CSS selector. If we really wanted to, we could say something like await page.getByText, and say something like get started. We could do something like that. We could do something like get by a test ID if we had test IDs put on the page, or we could just say straight up page locator. I don't know, and put like X path equals whatever. Right? You can use the locator method as well. It's all good. So anyway, we create a locator for the desired element. Then we call the interaction on that element. So here we want to click whatever this this button is or this link is. There's a bunch of interactions. If you're using VS Code, then you can see control space, all of the methods that you can do. You can check status of things like is it enabled, is it hidden. You can clear it, you can click it. Pretty much anything you can do with the browser, it's possible. The nice thing is that you don't have to explicitly wait for anything. Playwright will, by default, wait for up to 5 seconds for the thing to be ready before you interact. That's why this is not an element, this is a locator, and it uses the locator object to smartly fetch that element once it's ready. Finally, we have assertions. The assertions are done through the expect function. We're expecting something to be true of the page, so expect the page to have a URL. So we're checking part of the URL. You can also check the page to have a title. You can also expect things to be true of elements on the page. So you can say like, await, expect page.locator, I don't know, whatever, to have text or to be visible. Oops. You can see all the different assertions available to you for Playwright. So there's a bunch of cool stuff you can do. If you want to see those more interesting tests, the ones that are a bit more complicated, I shouldn't say complicated, a bit more complex. Here we can go to the demo to-do app, describe your new to-do. Test should allow me to add to-do items, should clear. You can see how the code it's bulkier here because it's doing some more serious testing. You can see there's other kinds of things like filling text, pressing keys, expecting things to be true by giving a list of text values versus just an individual one. And anything you can do with testing, you do with Playwright. Now, I only have half an hour. My time is almost up here. So I'm going to pause here. If you want to learn more, definitely check out the full tutorial. There's actually a Trello-like app you will run locally on your machine and write tests against that. I'm showing that here. I don't have enough time to show that today. That's okay. So let me stop, move over to the chat. Let's see if we have any questions. Aaron, preach. Yes, this information is so good. I wonder if people are taking notes. Thank you. Oh, thank you very much. David, Olola, could we have alias to replace the await? Too repetitive. Um, I understand the the issue of like constantly typing the await command. If you've done JavaScript async programming before, this is just par for the course. There's no alias to get rid of it, at least as far as I know. These are keywords in JavaScript and TypeScript. So you're stuck in the async await kind of thing. Um, Ganesh, I have a generic question. Can we measure application code coverage using end-to-end UI cases? I know it's not ideal, but yeah. So technically, there are ways and means to do that. What you have to do is you have to instrument your application code. So depending on what it is, if it's like, web app or desktop, you're going to have to instrument the code, the system under test's code, such that it can gather, trace, or whatever. Put that in place. Then you run your tests. You gather that data, and then you analyze it. It's not as straightforward as say like unit testing, because unit testing you have direct access to the code. So I mean that's why most unit test frameworks work hand in hand with code coverage, because they have access to the code. They're right there. End to end, it's a bit more complicated, because then it's also like, what are you testing? Are you testing some distributed architecture with like an event bus, microservices and all? Is it just a monolithic web application? How you will go about depends on what you're trying to check. So cool. Any other questions? I don't see any in the chat. So Sohit, in one of your slides, you mentioned Playwright tests UI and API tests together, and that's one of the advantages over its competitors. Could you please throw some light there? Yes, absolutely. So Playwright has full API support built in, right? In fact, if we look at those other tests I'd mentioned, the Trello-like tests, again, take the tutorial if you want to see those. I have a quick example where in my test that I'm describing for the Trello-like board, before each test, I am calling an API to create a new board in that application so tests can use that board. This doesn't necessarily test the API, but rather uses the API to prepare test data for the UI tests. And you can see right here, it's an HTTP post, goes to localhost on this port with this resource path and giving data. You could use it for testing, like actually targeting tests for the APIs as well. It's all a matter of what you want to do. Fun session. Thank you, Prashant. Leonardo, Andrew, do you think that Playwright is a good tool for developers make unit and component testing of their code? We have lazy developers too. So Playwright is not necessarily a unit testing framework, right? Playwright is meant to be testing APIs and UIs, which are inherently black box, which means they're going to be at the integration or end-to-end levels. But you can use Playwright for component testing, which is kind of like a UI unit testing, I suppose. There is experimental support for component testing in Playwright. I simply don't have a component library handy that I could demo that, but you can go to the Playwright docs, look up component testing. You can read how to set it up. It works for the frameworks like React and Vue and all the major ones. Hey, everybody, thank you for joining my session. Really appreciate it. Hope you all learned a lot.